the aim for this session is that we will build a finite state machine model, an example of it, and basically start our journey learning how to use WebGME. The first steps when you install the environment, so you're having the WebGME CLI, your node, and all the other tools that is necessary, is that basically you have to initialize your project, which will create an FSM directory for us. So that's basically our project, and we will work with that project throughout the whole day. Now it should be almost empty, but basically it's also a Git repository skeleton. So, and using the WebGME CLI, we can see that right now there is no component which we would have, so which we created. It's not even initialized, so we will start by initializing our project, and I will do the npm style installing. That will install all the dependencies for a basic project. So now the installation finished. So when you start the npm way, you just hit npm start, and your deployment started, and the basic port is 8888. So I can tell you a little bit about the UI, how it looks like, and then we can start on working on our model. So as Peter mentioned, we have different pieces and terminology. So we have panels. The main panel is the modeling panel, which is for the main visualizer, which is controlled by this left-hand side panel. Here you can see the valid visualizers for the given context or the project as it is. Underneath it on the left-hand side, we have the so-called part browser, which is a list of the available objects or the valid object of the given context. On the right-hand side, there's the usual object browser or tree browser that has 3 tabs. The first is the composition, so the containment hierarchy can be seen here, and you can navigate throughout your entire model. The second tab is the inheritance, which is similar, but it shows you the inheritance hierarchy. And the third one is the crosscut, which is, as Peter mentioned, is a special relation set or list, and it helps you navigate throughout those ones. Last but not least, the property editor shows you the editable and the not editable properties of the selected object. Right now it shows the model, the FM receiver model properties. So you have the attributes, the pointers or relations. We will see some meta information, and finally some visual preferences that we can change or set up. So we have not talked about the navigator bar, or which is a breadcrumbs like navigational panel. This is the place where you can create new projects, and as the FSM name is taken, we use a similar one. So this is how you start to create. You give your name, and then there is basically 3 options. We will use the seed option, which means that you use a snapshot of an already existing project or a file which exists on the deployment that as the base of your project. You can duplicate any of your project, or you can import any project packages as the start point of your new project. We will start from the empty project. So 2 objects that comes with the empty project is the FCO itself, which is the root of the inheritance tree, and the root of the containment tree. So they can be changed, but they cannot be removed or moved around. So when you start modeling, you basically want to start with building your language. So the best place to do it, or almost the only place, is the meta editor, which Peter mentioned is a special visualization of the meta rules that are already defined and kept inside each and every node. To create objects here, we already can use the part browser, and if you just drag and drop it from the part browser, it will create you an instance. It helps you with the name that it's an instance, and as you can see, we haven't set anything, although the inheritance relationship already visible, because that's something you are not really in control of. Okay, so first let's create a container for our language. And then set the rule that it can contain any type of objects. So as you can see, there are the different type of relations or meta relations that you can define by basically hovering over the source object, dragging the pointer, and ending up on the target object. So this way, we define that the language object already able to contain any type or any subtype of FCO, which basically means that any object can be contained by the language object. All right. Here you see the meta, which is basically an aspect of your meta, and you are able or you are allowed and welcome to create new ones so that you can group your language definitions, and that way they will not be overly complex on a single screen. Keep in mind that although there are multiple tabs, if an object is there on some of the tabs, it is part of your language throughout the whole project. If we switch back to composition, you see that the language object already there. For the other elements of our FSM language, I would like to show you, let's say, different ways how you can create objects. Again, you can use the part browser. So we can say that, okay, inside the language, I would like to create an FCO instance. Let's just rename it so, or not, that this one will be the state machine. This object currently not part of our language because we created it in the composition view. It means that it's part of our project, it's part of our model, but it's not seen as a language element. Another way how you can instantiate objects is dragging from the object browser or the tree view, and again, this already created an instance, and we will need this instance. Let's call it folder. All right, let's get back to the meta. And as you can see, nothing changed here. But how you can add elements is just simply dragging and dropping from the object browser, and now they are part of our language. As you can see, when you are using the meta visualizer, the part browser basically shows you all the elements that you have in your language. When you are in the composition, for example, the state machine doesn't currently have any containment rules, which means that it cannot contain anything, so the part browser will be empty. So we create the folder, so we will have a placeholder where we can contain our state machines. And then we would need a few other objects. We would need a state base, we would need a transition, the state base to our language. So if I just want to have a subtype, I just drag and drop the state base, and I can call my subtypes and have it there. So we will create 3 subtypes of the state base: the initial or starting state, the state itself, and the end state, which we will call end. All right. So now we want the transition to be a connection. The relations or the pointers are arbitrary ones, so you are welcome to label it as you like. But if you want to use uh, the default UI, let's say, then there is a source and destination, which Peter mentioned, that will trigger to visualize the transition object as a connection. If you create your own visualization, you can handle any relation as a line. It's up to you. So this is how you create your connections. Now again, go with the containment. We wish the states to be contained in the state machine, and of course transitions can be contained in the state machine as well. And we would like to have some cardinality rules regarding the initial state. We want any state machine to have at most one of those. So you see this 0 dot dot asterisk, that's the cardinality rule, and you can, by double clicking, pop up the editing or in place addition, and then you can change it, which means that whenever we will see when we build the example, but this means that although any number of state bases and its subtypes can be contained by a state machine, there's only at most one initial state that can be in a state machine. All right. Now, one thing, we don't want actually state bases to be instantiated in our models, so we want it to be abstract. In the property editor, in the meta tab, there are a few things that we can set. We will talk about later what the valid plugins and valid visualizers means. For now, we will use the isAbstract to say that although this is part of our language, it's not something that we want to instantiate. And you can see again an example of the prototypical inheritance, because the 3 subtypes immediately became abstract as well. But of course, we would like them to be instantiated. So we select all of them. Because all of these seen as abstract, now we can change by a single click for all 3 that, okay, now you are not abstracts. What you can see again in the property browser here is that it says that it is overwritten its inherited value. If you wish, you can clear that out, and that way it's becoming again the value it's inherited from its base. All right, let's finish up our model by adding an attribute to our transition, and let's call it event. When you named your attributes, you have the option to switch a type for it. These are the basic types. You can give a default value. For strings, you can give regular expressions. You can use enumeration. We need 2 more attributes on the state machine just to allow our upcoming plugin to function properly. Simu. So one is the simulator, right? And this one is a special type. It's an asset type. The asset basically, so with every WebGME deployment, we have a blob as well, where we can store arbitrary artifacts, any kind of file, which is again a hash-based storage place. And we also need a simulator origin. That is a plain string. So these are the necessities of our languages. And before we drop into the example building, I'd like to show you all the elements we grabbed from the part browser inside the meta editor are actually created under the root. And now I want them to be in the language folder because that's where they should be. So when I drag and drop from the object browser, there's a pop-up window telling me what can I do with it. Right now I would like to move them. So I move all of them. And if you can see, it doesn't allow me to move the state base. And the fact that it's not allowed me to move the state base is because it's abstract. So I have to go back here, temporarily set it back not to be an abstract, and then I will be able to move it under the language folder. All right. So if you open up the Preference tab in the Property Editor and you selected the language, you can see that there's 3 item related icons, and under the 3 dots there is an icon library basically, which you can use, and of course you can add your own to your own deployments. So let's select the document because it's like a blueprint for our language. And then the other icon we would like to replace is the folders icon. So if once you are in the object browser, but you don't want actually to navigate to that given object, but you still want to see the properties of that object, you have the option to right click and then say select node. That way the property editor will show you the properties of that node. So let's change the icon. It will look like more as a folder. All right, now we are really finished with our language. So let's build a small example that we can use. First, we would need a folder where we can put our examples. You see that because this is a folder, you are only allowed to create state machines here. Our basic example will be the deployment process, or at least some schematic version of it. So again, for the cardinality, once you put, so it becomes gray, meaning that although it's a valid object, because of the cardinality, you should not put any more inside this object. Then I will drop a few states here, and we will name those. We have 2 end states. All right, so the initial step in our deployment process is when we have a new version available, so we would like to deploy it. Then we install it, and as you can see, whenever I start the dragging from a selected or highlighted box, it shows me all the boxes that I can connect this to. Because we have a single connection, it will not ask what type of connection I would like to create here, because as I said, we have a single one. So the first transition, we'll have the event that the npm installs. And this state will be our installation complete state. Okay, then we will have a failure state if something would go wrong. And after the installation, so basically we can already go here if the event is that the npm install fails. But let's assume our installation completes. Then we would like to run some tests on our deployment. And when it's finished, we can say it's live tested. So to reach the live tested state from our installation complete, we would need the transition that testing is actually succeeds. Of course, testing can fail as well. So we will have an event for that. Finally, the two end states is one, we deployed basically, and the other is that we not deployed. And the transitions we have is that to say that we are finished with the deployment, we still have to notify our users. So when the users are notified, then we can say that we are finished with the deployment. We cannot really fail the notification, but when we failed in earlier steps, we want to have a stable version on our deployment, so we say that we revert back to the original version. Let's call it revert. As you can see, it's not visually appealing, like visualizing the events where the transition flows, so was the source and the destination. Again, prototypical inheritance. So let's look up our language folder and let's check the transition. In the toolbar, you can see that we have starting and an ending pointer. So let's just pick one. And if we go back, all the transitions now have arrow endings. And to visualize the event, instead of the name, in the property editor, in the preferences tab, you can see a display format. In this display format, you're allowed to combine a few strings. The default is the $name, which means that you wish to visualize the value of the name attribute of the given node. But right now we want to have the event. Of course, you would be able to have like event dash name, and then it would show the event and the name of the node. So this way you can combine. You can basically show any attributes the node have. But right now we will just use the name. Oh, sorry, the event. All right. So now our example is complete. So what we will do is that stop the server, and then I will instruct the WebGME CLI tool to add the component as a seed, and I will call it FSM. So this is the command WebGME new seed FSM. What it does, it basically look up your deployment for the given project, it exports it, and it stores it among the seeds, and it updates your configurations. So the next time you start up your server and you want to create another project, you can use the FSM as seed.
And when there's a conflict, what capability does the user have to resolve the conflict manually?
So we will create a new branch from master, and we will call it like something or B1, B2, doesn't matter. So now we have two branches in the project history attached to the same commit. So we are in the master branch, we can make a change, like move the state machine, for instance, to somewhere else. Then we can switch to B1, to the B1 branch, and we can move the state base. Let's move the state base, and let's click on the state machine and rename the state machine, but don't move it. Rename the state machine, that will be the state machine 1.
Sorry, are you creating the conflict here? Or?
Right now we don't. So right now we will show what changes you can make to not create the conflict and how WebGME will handle it in terms of merge. Then we will create a conflict. We will show you what possibilities you have to resolve that conflict, if that's fine.
Great.
So if you go back to the history, Tamas goes back to the history, the project history. Now you can see that we started from the same point, and we made one change in the master and two changes in B1. And we don't expect these would be conflicting changes because we changed the position of the object and the name of the object in B1, and we changed another object's position in master. So right now we would like to get, let's say, to our, we would like to get the changes to B1 from the master. Can you do that?
Yeah. No.
And what we expect is that the position of, after a successful merge, because there were no conflicts, the position of state machine 1 changed. So that was the position in the master, but the rest of the model remained the same. So now what happens if we rename state machine, and we can see also the merge. Now what happens if we rename state machine 1 to state machine 22 in one branch? See an easy conflict resolution, and in the other branch we will rename state machine to something else, state machine 99, for instance. So we changed the same attribute of the same object in two different branches. These will be conflicting changes when you try to merge the branches. So in B1 we try to merge the master branch in, and it will detect the conflict and it won't merge the two branches for you, or the two versions, and it will list all the conflicts that it detected, and you can pick which one you would like to choose to resolve your conflict. So you either pick state machine 21 or state machine 99. We also provide hyperlinks to the objects, so if you click on it, it opens up in a new tab, hopefully. So you can inspect the state of the model to see which one you should pick. And you will have, if you go back to the conflict resolution, you will have three options. You pick either yours or theirs, or you abort the change or the merge, and you try to make sure you change the branches in a way that it won't get conflicts. There is no third option, so you cannot type in a new name as part of your conflict resolution in this case. But if you select like state machine 99 and resolve it, or the other one, then it will rename, after the successful merge, it will rename it to state machine 99.
So I have a couple follow-up questions.
Okay.
Do you mind?
No.
Okay. So is that similar to what will happen with multi-user on-the-fly editing? So like if one user makes a change while the other user has the same model open, and it creates a conflict like we said, does it ask you to manually merge, or does it bring up this red thing saying there's a conflict?
So Peter mentioned that we generate all the new objects and the commits basically on the client side and send it to the server, and the server will insert it into the database, all the new objects. But when there is an online collaboration, and if you are in a branch and other users are in the same branch, there could be a race condition in which you are already out of date because other users basically won that race, and his changes are already on the server and in the database. In that case, we have on the footer in this toolbar an in-sync notification area, and if you get out of sync from the current branch because another user is already ahead of you, you will have a notification here that you are out of sync or ahead. You can either create a new branch, or you can try to, with one button click here, you get a menu, and you can try to merge to the latest branch whatever changes you made. And you get the same dialog box. If it was successful, it goes in. If it's not successful, you have to deal with the conflict resolution.
So creating a new branch would be like a stash, kind of, maybe?
But let's make it clear. It is really just it can happen if there is a serious race condition. We are talking about the millisecond or worst case second scale, where you are actually editing at the same time. Just by opening the model on multiple users, it will hopefully rarely happen that they really do conflicting changes within the same second.
Got it.
So that's just, I just want to make sure that.
Right. Or another option, if you lose your internet connection for a few minutes and you make some changes and you don't need any objects from the server, you will be ahead of whatever the server knows about, whatever that version is. And when you get reconnected, all of your changes will be pushed to the server.
If there are multiple users and they want to edit different aspects of the model, is there a way that is there a set of steps that we can follow to say, you work on this part of the model and I won't touch? I don't know if there's a model level lock available.
So we don't have like an SVN lock per folder, if that's what you are looking for.
Right, but branch level?
Not even branch level. Peter?
No. We have very strong feelings against locking.
Okay,
this is what we tried before, and it really flies against these model-based artifacts. That's what I can.
What should I tell?
So what I can tell you again is the same thing that I talked to James, that you can work on different parts, right? So the only problem comes when you start working offline, which is kind of against what we are preaching with this online tool. So, sorry, if you are working offline, you are on your own with the conflict problem. Typically, we hope you can work online, and then you can work concurrently, and you don't even have to set ground rules because all the changes are propagated for the other clients. So there's a very, very small time window where intermittent conflicts can arise.
Okay. So if I hear you right, allow the users to work on the model or separate folders and let them create tags whenever they are think that that's a level where if somebody makes an edit or change, then they can go back to that or things like that, and then go on. I mean, finally, when somebody has finished this set of models and the other set of models, and you want to create a system level model, you call a timeout and then you merge things.
Or if, so one more thing is the libraries, right? So if you really want to separate work and you have some high level integration, then you can try using the library feature. So everybody has its own project, right? And this big integration model just can bring in the projects as library. So you can try that workflow as well.
Okay.
It's a valid work.
Okay. I have to advocate something tomorrow or day after, so I need this answer immediately.
No, the question that may have been answered, but I didn't fully get everything. So if there are two concurrent users working on distinct parts, there's no conflicts, nothing, but one changes their minds and says, I hate everything that I did, but the other one is perfectly fine with their actual contribution. what is the resolution mechanism
Yeah,
for?
yeah. The first user have to work it back.
So like manually undo as opposed to roll back.
Right. Right. I mean, it's the same thing. What, for example, what would happen if you happen to work on the same Google document, right? You just
Yes, but here there's a heavy notion of containment, which would allow potentially to say localize the set of changes and say I want to unroll the changes within this soft containment that had nothing to do with the rest of the model.
Yes, but
So I'm saying that the luring potential of facilitating these features is
So if we would have to resolve or have to think about along the containment links, then 99.9% of the efforts that we have to put in this tool will just vanish because if it is really a nice containment hierarchy and there are no cross-cutting links, then everything is simple. But the cross-cutting links which makes it extremely complicated.
That's yet another reason why we chose that the libraries are full projects. And we
libraries are
the libraries that you can attach to a certain project, libraries themselves are full projects, which has the meta, which has everything, because we don't need to cut that subtree with all the outgoing and incoming links and recreate them if you can recreate them, right? So that was the reason why we chose that the libraries are full projects and you just delete what you don't need. And again, I would like to emphasize that we save every single version to your project. So if you say that you would like to roll it back, you just go back in the revision history and either tag that version or create a new branch and you can continue from there.
So when the two people are working in different branches, you can have where they want to merge. Instead of merging just a diff store. So if somebody just wants to inspect what are between these two branches, then you can basically use the same code that you have for diffing, but it is a new menu item.
Yes. So Peter mentioned when he showed a slide about the different layers in WebGME, and we have REST API support to get the diff between two versions of the model. It's going to be a plain JSON object. If you would like to create a visualization for that would be something to show to the user. We don't have that capability in terms of the visualization capability, but we do have a capability to generate a diff between any two versions of the model.
Yeah, that was a nice addition. Some questions regarding the model library. So, can you import multiple libraries that were based on the same meta?
Yes, you can, but they will contain their own version of the meta.
Okay.
So you can import this FSM from one version and from another version to the same language, but you will have the meta duplicated basically for each version. Yes.
So when you were making the list model, the FSM, you had to go through back and forth between meta and composition to make the language. I'm just wondering, why did you have to go back and forth between the two?
Right. So in the old GME world, you had the meta model as a separate project, interpreted the meta model, and then you loaded that meta model in an environment, and GME was customized for that language. In this case, the meta model is contained in the project, and the instance models are also contained in the project. Which means that in your composition hierarchy, you will have elements that are either part of your meta model or they are not part of your meta model. How you organize your containment tree, it's up to you or up to the user. We tend to organize it in a way that we create a language folder and we put everything, all the concepts into the language folder that is part of the meta. And when we switch to the meta view on the left-hand side, this is not a containment relationship. It's like a visualization technique to show what is part of the meta. And to make something part of the meta, you need to drag and drop it from the tree browser or from the part browser. So the reason why you need to switch in between. Another option is you can split the view, and you can have a split view in the same browser window, and you can have this way on the right hand side the composition view, on the left hand side the meta, and you can edit both at the same time if you have big enough screen. Our resolution is not that great on this projector. I hope I answered your question. So you need to switch back and forth as you're building up your language. Once your language is finalized, then you can use only the composition view because you're not changing the meta. Other questions?
Just to continue that.
Okay.
So once you have your language built, do you then ignore the language folder on the right-hand side and you only use the, so essentially the children of SEO on the left-hand side?
Right, so what you can do is you can treat the language folder as complete and nobody will change it, right? And you can configure your own deployment that the root of the composition will be your examples, for instance. Which means that when a user opens up your project, they start from examples, or as you have seen, like in Brian's case, the visualization technique, he didn't show his meta model. I'm pretty sure he has a meta model, but he showed only like architecture diagrams and training, other models. So you can hide certain part of the tree browser by saying that the examples is your new root, or you name it project, and that's your new root. But still, the language, the meta model, and the meta model elements and rules must be part of your model and that version, because that's how all the different widgets are operating and querying the rules. And as we, our suggestion is usually when you start building up your language or use WebGME, you will start probably with this generic UI, and it's good for a certain amount of time. After that, you may want to finalize your language and not show it to the users. And after that, you may want to create a custom decorator. And after that point, you may want to replace the entire UI with something else. But still, you can get back to this generic UI all the time. And because it's generic UI, it has no knowledge about the actual domain, and we would like to leave it open to be applicable for any domain, whether it's medical field or education or complex system design. These are the key concepts that we can show you in the generic UI.
Can you talk a little bit about constraints and constraint specification, constraint enforcement?
Yes, so because we mentioned that only the objects are downloaded to the clients that most likely the client will use. So as you open up the tree, it will fetch the next level of objects. On the client side, we don't have all the objects. So if you change your meta model, we don't evaluate your meta model against the entire project tree, because, like for instance, Hakan had a project with almost close to 1 million objects. Just imagine for every single change we would evaluate on the entire containment tree all of those rules. So what we say is you can be in an inconsistent state, meaning you can freely change your meta model, go through more than one inconsistent state, and after a while you say that, okay, my meta model has changed. Now I would like to evaluate all of my meta rules starting from the root or from a certain subtree and get the feedback whether my model is still valid or complies with the meta model or it doesn't. And that can be done. There is a constraint checker button on the toolbar, the left hand side, and you can check the meta rules for an entire project or a subtree. So that's the meta rules part of the constraints. And you can write custom constraints using JavaScript. So for every single node in the meta view, if you go to the meta view, you can see there are attributes and constraints. And when you click on the plus button, for instance, to the state, you can name your constraint. That will be the name of your constraint, and you get a place where you can enter JavaScript code and return with basically a true false value as well as with a descriptive message what that constraint does. And you get the core, access to the core API, as well as access to the node on which the constraint will be evaluated. And this uses the exact same API that the plugins are using. So if you have implemented some code for your model transformation, you can reuse it for constraints, if you like. But again, the constraints are not evaluated for after every single change. You have to invoke the constraint checker, if you will, for each context that you would like to check all the constraints.
And you might need to load the tree here or something like that.
Yes, so if you get the current node that you get, it's already loaded to the client side. But if you would like to do more sophisticated constraint checking, so Nog had a really good point, then you are responsible of loading all the objects that you need for the children or pointers, outgoing pointers, because they may not be available on the client side.
So programmatically
Yes, programmatically in the constraint checking. And while we are here, I would like to say that you can rely on objects are all the meta objects always loaded. All the parent objects are always loaded according to the containment tree. So if you get an object somewhere in the tree, all the parents are loaded and all the base classes are loaded. So these are the three different types that are always loaded, and you can rely that those objects are available for you. But in general, it's good to assume that it's not on the client side and you just request the load. And if it's not available on the client, it goes to the server. If it's available in the client side, you just get it from the cache.